Area of other quadrilaterals. So far, we've discussed calculating the area of squares, rectangles, triangles, and parallelograms. We move our attention to the rhombus, kite, and trapezoid. The rhombus review. A rhombus is a quadrilateral with four congruent sides. If AB is congruent to BC, is congruent to CD, is congruent to DA, then ABCD is a rhombus. Note, ABCD is a parallelogram too because its opposite sides are congruent. So a rhombus is a special parallelogram. A rhombus is a parallelogram. The diagonals of a rhombus are perpendicular. The diagonals of a rhombus dissect the rhombus into four congruent right triangles. Area of a rhombus. A rhombus is a parallelogram. The area of a parallelogram is given by A equals BH. Since a rhombus is a parallelogram, the area formula for parallelograms would apply. So given that PQRS is a rhombus, the area equals B times H. So we have the base here, and then the perpendicular height up to the other base up here. There's some other ways to compute the area of a rhombus. The diagonals of a rhombus are perpendicular. The diagonals of a rhombus dissect the rhombus into four congruent right triangles. The area of a rhombus is 1/2 the product of its diagonals. A equals 1/2 D1 times D2. Given PQRS is a rhombus, the length of its diagonals are D1 and D2. The area of the triangle here equals 1/2 of 1/2 DI times 1/2 D2. So it's 1/8 D1 times D2. So the area of PQRS is 4 times 1/8 of D1 D2, which is 1/2 D1 times D2. Kites review. A kite is a convex quadrilateral with two pairs of adjacent congruent sides and whose opposite sides are not congruent. A kite has one pair of opposite angles that are congruent. The diagonals of a kite are perpendicular. The area of a kite equals 1/2 the product of its diagonals. A equals 1/2 D1 times D2. This is the same formula as the rhombus. The area of a kite equals 1/2 the product of its diagonals. Here's a proof. So we have a kite here. If we take this purple triangle here and move it to the top left over here, we get this. And if we then take this green triangle and move it over here, we get this. So we can reform this kite as a rectangle whose area is 1/2 D1 times D2. In the kite on the left, the two smaller triangles are congruent, as are the two larger triangles by ASA. In the figure on the right, the congruent triangles are rearranged to form a rectangle. Lengths as indicated demonstrate the theorem.